The performance of large language models on reasoning tasks such as mathematics and programming has always been an important metric for measuring their capabilities. Recently, DeepSeek released their reasoning model, DeepSeek-R1, which achieved an accuracy rate of 79.8% in the AIME 2024 mathematics competition test, comparable to OpenAI's O1-1217 model. This achievement was hard-earned. Let's delve into the story behind this model. This video shares a paper published by the DeepSeek team titled DeepSeek-R1, Incentivizing Reasoning Capability in LLMs via Reinforcement Learning. The development process of DeepSeek-R1 was very interesting. The research team first attempted a bold idea to let the model learn directly through trial and error, i.e., reinforcement learning, rather than giving it a large amount of manually annotated answers to imitate, i.e., supervised learning. Specifically, the model would attempt to solve problems and then adjust its strategy based on the correctness of the results, just like humans master skills through practice. This experiment, known as DeepSeek R1-0, has yielded surprisingly positive results. The model has gradually developed human-like thinking habits. For example, when solving math problems, it actively checks whether the answer is reasonable verification, and if it finds an error, it rethinks the solution method reflection. This self-directed learning approach enabled the model to achieve a 71% accuracy rate in the AIME 2024 math competition test. However, DeepSeek R1-0 also has some issues, such as poor output readability and language mixing. To address these issues, the research team developed the official version of DeepSeek R1, adopting a multi-stage training process. 1. Cold start phase. Initially, thousands of high-quality reasoning example data were collected, and the DeepSeek V3 base model was preliminarily fine-tuned. These data included detailed chain-of-thought examples, helping the model establish basic reasoning patterns. 2. Reasoning-oriented reinforcement learning, reasoning-oriented RL, after the cold start. Training is conducted using a reinforcement learning method similar to DeepSeek R1-0, with a focus on reasoning tasks such as mathematics and programming. 3. Screening and supervised fine-tuning, rejection sampling, and SFT, when reinforcement learning approaches convergence. The research team conducts screening and sampling of reinforcement learning checkpoints to obtain high-quality inference data, and combines it with supervised data from DeepSeek V3 in areas such as writing, question answering, and self-awareness, using this new data to retrain the DeepSeek V3 base model. 4. Reinforcement learning for all scenarios. The final stage, considering prompt words for various application scenarios, additional reinforcement learning training is conducted. This multi-stage training approach not only maintains the model's strong reasoning capabilities, but also significantly enhances the readability of the output and multilingual processing abilities, enabling DeepSeek R1 to achieve a level comparable to OpenAI O1-1217 across various tasks. In the evaluation, DeepSeek R1 demonstrated comprehensive capabilities in mathematical reasoning. Its performance in tests such as AIME 2024 and Math 500 was comparable to OpenAI's O1-1217.in programming. It achieved a score of 2029 in Codeforce's competitions, surpassing 96.3% of human participants. In terms of knowledge tests, DeepSeek R1 has also achieved good results in tests such as MMLU, although slightly lower than OpenAI's O1-1217. It is significantly better than other closed-source models. DeepSeek R1 also performs excellently in general tasks such as creative writing and Q, and it achieved an 87.6% win rate in the Alpaca Eval 2.0 test and a 92.3% win rate in the Arena Hard test. Even more surprisingly, the research team also explored the method of knowledge distillation, transferring the capabilities of DeepSeek R1 to smaller models. They released 6 open-source models of different scales, 1.5B to 70B, based on Quinn and Llama. Among them, the 14B scale model has already significantly surpassed the current best open-source 32B model, QWQ 32B Preview. In terms of technical implementation, DeepSeek R1 employs an innovative reinforcement learning approach. The research team utilized the GRPO, Group Relative Policy Optimization, algorithm which is an improved version of the PPO, proximal policy optimization, algorithm. Imagine if training a model is likened to teaching a student. PPO is like a cautious teacher, making only minor adjustments to the student's behavior each time to avoid overcorrection. GRPO, on the other hand, is smarter. It allows the student to try multiple problem-solving methods and then guides the learning by comparing the effectiveness of these methods. This not only enhances learning outcomes, but also eliminates the need for a scoring standard value network required in traditional PPO. Specifically, GRPO samples multiple outputs for each problem and then uses the relative scores within the group to guide the model's optimization. This method saves computational resources while maintaining training effectiveness. In terms of reward design, the research team constructed a multi-level reward system. The accuracy reward requires the model to provide the final answer in a specific format, e.g., within a box, to facilitate automatic verification of correctness for programming problems. It evaluates by running preset test cases through a compiler. The format reward requires the model to place the thinking process between think and /think tags, ensuring structural integrity and readability of the output. The language consistency reward guides the model to maintain language uniformity in responses, avoiding the issue of mixing Chinese and English. The effectiveness of this training method is remarkable. In mathematical reasoning, the model can clearly demonstrate problem-solving steps and perform self-verification. In programming tasks, the model not only writes correct code, but also actively tests and optimizes it. In knowledge-based question answering, the model first conducts reasoning analysis and then provides the final answer. This structured way of thinking makes the model's output both accurate and easy to understand. Of course, DeepSeek-R1 currently has some limitations. Capabilities in function calling, multi-turn dialogue, and complex role-playing are not as good as DeepSeek. V3 that there may be issues with language mixing when handling languages other than English and Chinese. IT is sensitive to prompts, and using few-shot prompts may reduce performance. Improvements in software engineering tasks are relatively limited. The research team plans to focus on improving these issues in future versions. They also hope to promote the development of the entire field through open source, enabling more researchers to continue exploring based on their work. The significance of this work lies in: for the first time, it has been verified that pure reinforcement learning can cultivate the reasoning ability of models, pointing the way for future research. At the same time, by open sourcing models of different scales, the research threshold has been lowered, allowing more people to participate in the research of large models. That's all for the main content of this video. The success of DeepSeek-R1 once again proves that openness and sharing can accelerate the development of AI technology. What are your thoughts on this new model? Feel free to leave your comments and discuss below. Thanks for watching, and see you in the next episode.